Hi all. Today we'll discuss about uh, an important concept called advanced processor technology. So the advanced processor technology is with respect to the processor, what are the latest processors that are being used, and what is the latest technology that has been implemented for the processors in today's world. We'll see all those details. So first I'll tell you how the advanced processor technology is learning of advanced processor technology is important with respect to the processors. We know that whenever we execute a processor, whenever we want to execute some instructions, we require to have a processor. And this processor is the main component in the CPU. And before going to discuss about advanced processor technology, one should know that a processor is a combination of ALU plus some processing. A processor can have ALU, cache, and some special purpose registers. We have been saying that this is called a processor, and we have seen that there is a in a conventional computer we use a, a normal processor or a uniprocessor system, and then which performs sequential computation, and this is not sufficient for performing large computations, so we said it is required to have parallel processing technology. So the motivation behind going to parallel processing is we need to execute some large complex programs or large programs which performs computations, large computations, and the uniprocessor or a normal conventional computer takes days or even weeks together to execute such computational some programs related to computational problems. So it takes huge amount of time. So it is required to implement some parallel processing technology when compared to sequential processing or sequential computing. This is the motivation behind implementing uh, parallel computing. And you know, parallel computing can be implemented by different technologies. We discussed about how parallel computing can be achieved. Parallel computing can be achieved mainly with a single computer with multi-processors or a group of computers. And group of computers computing is called the parallel computing that is implemented in a group of computers is called, it is known as grid computing or cloud computing, and it is beyond the scope of our syllabus. Let's try to strict our discussion to the parallel computing implemented using a single computer with having multiple processors. When I say single computer with multi-processor, again we can divide it as multi symmetric multiprocessors or tightly coupled systems or loosely coupled systems. In case of tightly coupled system, there are multiple separate processors, peer processors. Each processor has the same capability of accessing main memory and IO resources. It is one type. It is called symmetric multiprocessor, and all the processors share a memory and system bus and access IO interfaces with equal opportunity. It is called tightly coupled multiprocessor, and the processor which has uh, pipelining technology. And if you have a uniprocessor system, if you want to achieve parallel computing, still it is possible. So it's not like if I want to implement parallel computing, I do require to have only multiple processors. It is not required. Even with the single processor, even with single processor, this multi parallel processing can be achieved by using a technique called pipelining. And you know that pipelining is a technology which allows us to execute the instructions in parallel just by dividing the execution task into different stages. And of course there are vector processor and array processors, and today we will see how all those multi-processor technologies have been implemented in recent trends. What are the recent trends of processor technology, which is called advanced processor technology? So to explore what is the goal of this advanced processor technology means, we have to explore novel architectures and techniques that will enable effective exploitation of the billion transistor chips in a near future. So the goal is we have to explore a novel architecture and techniques that will enable the effective exploitation of the billion transistor chips in the near future. What are these transistors? You know about billion. Billion is really a big number. So the billion number of transistor chips are required to the processor. What a processor contains, hardware wise, what a processor contains means it contains transistors. How many transistors? Billions of transistors. And how to manage this billion, how to place all these billions of transistors, what are the consequences, how to manage all those things. This is the challenging task. So now we will discuss about the novel architecture. And in the novel architecture process, we've seen that to explore novel architecture and techniques that will enable the effective exploitation of the billions of transistors. So remember, these billions of transistors are very useful because while designing a processor, it is designed with a number of transistors, and those numbers belongs to some billions of transistors. used to design a processor chip. So there are certain problems, certain issues with deploying billions of transistors within a single chip. Remember, within a single processor, if this is my processor chip, single processor chip should hold billions of transistors. And the billions of transistors, the count is, you know, right, billion is means 100 millions, 1 million is equals to 10 lakhs. So 1 billion is equals to 10 crores. So some crores of chip, uh, some crores of transistors are being used in designing a chip, and there are certain issues while designing this. The first one is the heat that transistor generates. When you deploy billions of transistors, first they require more power. Somehow we should identify techniques which can reduce the power consumption. And also, when you deploy billions of transistors in a single processor, they generate heat. So it is also a goal to reduce heat generated by these billions of transistors. Now we'll focus on advanced processor technology group, that is uh, Moore's law. What is meant by a Moore's law? What Moore's law states is that it says that the number of transistors that are used in a processor almost doubled for every 2 years. So for every 2 years, for every 2 years, the number of the number of transistors used in the processor chip, number of transistors used in processor chip will almost doubled for every 2 years. Number of transistors count is doubled for every 2 years. So it is almost doubled for every 2 years. This is called Moore's law, but it is not a indefinite law. That means it is not implemented for years together. Definitely there is a certain limitations for this. Even Moore's proposed this. So the Moore's law will soon deliver billion of transistor chips. How do we make best use of these billion transistors? This is the major goal. The major goal is how best we can how best we can use of these billions of transistors, because with these billions of transistors you can do billions of or trillions of calculations. The billions of transistors, very important to note down. Billions of transistors can be used to perform calculation on trillions of operations can be performed. So you should identify, you should understand the word million and billion and trillion. So you should know all these words: million, billions, and trillions. So these many number of transistors are used. So when you have billions of transistors used, how to effectively use all those transistors which can perform trillions of calculations? That is the main challenging task here. And next one, how do we make best use of this billion transistors means whether can implement parallel processing. Remember, if I say parallel processing, there is a lot of technology that is being implemented for parallel processing. Even you can implement pipelining. You can implement pipelining or parallel processing, or you can do systems on chip, and you have to implement some novel architectures. See, this vector processor, array processor, these are the advanced, right? Like that, there has been so much of research going on how to design a novel architecture, different or new architecture, and Moore's law will soon deliver billion transistor chips. How do we make best use of billion transistors is again an important thing here. And next we see the strategy or vision. So this strategy or vision, what it says is that uh, when the industry shifts to multi-core processors, so you should understand this word multi-core processor. This multi-core processor, what does it do? What is meant by core? So you should understand the word core, then you will better understand the meaning multi-core processor. I will discuss some points about multi-core processor. Like, if you know, see, around 10 years back, when you purchase a mobile or a system, you might have seen this word in the configuration. That is dual core processor. Later on, quad core processor. Next, octa core processor. So these are the different processor technologies that have been implemented over a decade. So first dual core processor, then it is evaluated to quad core. First I will then octa core. I will describe what is meant by dual core processor. Dual core processor means if this is my processor, it has been divided into two cores. This is called a core. This is called core 1 and this is called core 2. So this is called dual core processor. So in the dual core processing, what are the elements it contains means it contains ALU. Each dual core processor contains one ALU plus one cache plus certain registers. So it's very important to understand that. What is that? A dual core processor contains ALU, cache, ALU, cache, and resistance. ALU, you know about ALU, it is called arithmetic and logical unit. And cache memory, it's an internal cache. And the next one is register. So what is meant by a register? Register means it has some special purpose register or temporary location that is used to store the data temporarily. You know about cache. Most frequently used data will be stored in cache. So the ALU, cache and register. This is called one core. So like that we have dual core processor means there is a 24 and 35, 36, 10, 46. Yeah. So the dual core processor, now you got an idea what is means by dual core. Next I have quad core processor. So what is meant by a quad core processor? Here quad means 4, dual means 2, quad means 4. So here the core is divided, processor is divided into C1, C2, C3 and C4. This is called quad core processor. So what happens here with this quad core processor, each core has its own ALU, computing element. Remember, ALU is one of the best computational element in the processor. Next to registers and along with frequently used data stored in cache. So if I say quad core processor, what happens here? It is divided into 4 equal parts. Similarly, I have octa core processor. So what is octa core? Octa means 8. Octa means 8. So here the processor is divided into 1, 2, 3, 4, 5, 6, 7 and 8. Here the processor is divided into 8 elements, 8 processing elements, 8 processing elements. So you should know what is the meaning of this processing elements means. They have been divided into 8 processing elements. So now the industry is shifted to multi-core processor. Multi-core means, as I said, it can be dual core, quad core or octa core, or even next generation is hexa core. Next generation can also be divided into hexa core processor. So directly addressed by our CMP network. Power and heat performance limiting. That means power, heat, power or heat is performance limiting. Asynchronous and low power design have growing importance. See, all these are basic words. Remember, all these things we discussed in the previous class. First, you should understand what is meant by asynchronous. See, first I'll tell you what is meant by asynchronous. Then she will shift why asynchronous is having so much of importance. Asynchronous means the speed of the sender and receiver need not be same. The first one. What is this asynchronous? Asynchronous is a technique for transferring data. So it is one of the data transfer technique. So asynchronous is one type of data transfer technique. So in this data transfer technique, what happening means so asynchronous is a data transfer technique. When this kind of asynchronous transfer technique is used means when both the sender and receiver speed are entirely different. You may have a high speed sender, low speed receiver, example processor and IO device, or low speed sender or high speed receiver like IO devices and memory or processor. So these are asynchronous data transfer. Then why you know about asynchronous data transfer? Then why it is taking so much of importance here means in this asynchronous data transfer technique, what we are trying to do, when I divide the processor into multi-core, C1, C2, multiple cores, and they have to access local memory or shared memory along with IO devices. So if you keep this shared memory, it is not a good idea. So it should not be tightly coupled. They should be loosely coupled. Loosely coupled in the sense each core should have a separate local memory and separate IO interfaces. So with this what happens? The communication tends to asynchronous. The communication tends to asynchronous. This is the major idea behind discussing about asynchronous and low power design. Have growing importance. The timing closure is a critical problem, acceptance of mixed timing and GANs. That means, as I said, if I have a multiple cores, for all these cores, there is a one control unit. Remember, the core contains just ALU, registers, and cache. The cores contain the core 1, core 2, core 3, they contain just ALU, registers, and cache, and not more than this. So when they contain ALU, registers, and cache, then they have only one common unit, that is one common control unit. The control unit is common. So when the control unit is common, you have to understand that the single control unit has to send signals to all these control units, all these memory, shared memory, and all IO devices. So it has to do everything. Single control unit, if the processor is not divided into cores, if I have a single core processor, the number of control signals are less. But what happens when you divide the processor into multiple cores and common shared memory, or each core with own its local memory and IO interfaces, the number of timing signals or control signals will get increased, and managing these control signals has to be done by the control unit. So its job, its responsibilities get increased. The timing closure is a critical problem. Acceptance of mixed timing and GALs. Design automation is vital. The next one is design automation is vital. What is mean by critical? Asynchronous automation must be competitive. because there are so many competitors who want to design this, and each one has to be unique in some way or other way. So this is the strategy of advanced processor technology. Next, can universities group design state of the art design silicon, digital silicon? Probably not in conventional processors. Few academic groups still fab digital chips. See, still some universities they design some chips. Is trying to take designs through the fabrication still a good idea? We believe so because reality matters, but the game is very tough indeed. So the point here is it is fabbed, it's manufactured. The digital chips are still manufactured by some universities. The next is buying a single core processor is difficult in today's world when the total world is moving towards the cores. Here I have a, let's take an example. Let's take this picture. But before this, let's try to discuss some points about Moore's law. See, the number of processors, chips, transistors used in a chip is getting increased over the years from 99 to 2011. They have been increased. Now, what I'm trying to say, if you take the example of this processor, which takes processor graphics, which takes processor graphics, there is a dedicated processor for performing graphics, for displaying video, for displaying audio, for performing multimedia things. We need to have a dedicated processor. And remember now, this processor, actual processor is divided into 4 cores. Next, we have a shared cache. Here, cache is also shared by these cores. Now, it is quite possible. Each core can have its own local memory, that is cache memory, or all the cores can have shared cache. Remember, here we have shared main memory also. They have shared main memory as well as shared cache. So the multi-core processor multi-core bring fundamental changes for computer science. Multi-cores bring fundamental changes for computer science because having multi-cores bring fundamental changes for computer science. Everything is changed fundamentally for a computer science. So what are the things that will change means the applications. Now applications will be developed based on uh, uh, by having an idea of multi-cores. The programs are designed for execute so that they can be executed by multi-core processor. So you have to design or develop an application, design an application or develop a program according to the multi-core processor. Next, I have some programming languages. These programming languages are especially designed to so that the instructions can be executed by multi-core processor. Android is one such example of a mobile operating system which is developed keeping a view on multi-core processor. Then I have compiler. The compiler is also designed to compile the programs developed for aim to execute this multi-cores. And runtime OS, runtime operating system or runtime OS is a very critical one, an important one when it comes with uh, runtime OS, when it comes with multi-cores. Next, the computer architecture itself. Next, computer architecture is also the computer total architecture has been changed, evolved with the multi-cores. Now, if you see an example of this multi-core, multi-core brings fundamental changes for computer science. Yes, it is understandable. But here you see the word Cortex, Cortex A15 MP core, and system agent and memory controller. If you look at the diagram, we have seen that processor graphics is a dedicated processor. Nowadays, when you purchase a computer, they separate graphic cards, VGA, so that can be purchased, so that they can be executed, so they can execute some multimedia kind of applications. Normal conventional computer, or if you want to perform normal computations, this processor graphics is not required, but it is required if you for video gaming, multimedia applications, such things. Next I have core. Just now I said core is nothing but which contains ALU and sometimes internal cache and some registers. So in this case what's happening, we are having this core is having ALU and registers. Core is having ALU and registers. So this ALU and registers, what they do, you know very well. And the point over here is that all the cores, the core 1, core 2, core 3 and core 4, all the cores are controlled by one common unit, that is control unit. One common unit, that is control unit. So the single control unit controls these cores. How it controls the cores? Just by sending some control signals. So the number of control signals will get increased with the increasing number of cores. If I have 8 cores, then the number of more control signals are required than having 4 cores. That is, if I say in other way, the quad core processor has less number of control signals compare with when you compare with octa core processor, that is 8 cores. And remember, all these cores have shared cache. All of them has shared L3 cache. All of them has L3 cache. Then there is another challenge that comes here is when all these cores wants to access shared cache, then how they communicate, how the cores communicate with the cache memory is much more important. You know, right? The speed of the core and cache is comparable. So we should deploy synchronous data transfer. It is applicable. Synchronous, they can share a common clock because they are very nearby. But the point over here is the speed of the core and speed of the main memory. All cores can access the main memory. Moreover, this main memory is also a shared memory, which is also still comparable, right? Which is also comparable. But the point here is how the cores communicate with the shared memory. How the core is communicated with the shared memory is an important aspect here. And remember, the speed of the core and shared memory is also comparable. The speed of the core, the speed of the core, the speed of the main memory is also comparable. So it is called synchronous data transfer. The speed of the core, the speed of the main memory is also comparable. So the communication can be synchronous data transfer. But if you take the speed of the cores and the speed of I/O interfaces, you cannot compare the speed of a core with the speed of the I/O interfaces. So here the communication has to be a synchronous data transfer. Why? Because here speed, you cannot compare the speed of core to the speed of I/O interface. Why? Because asynchronous data transfer has to be implemented. You know why? The reason for this, because the speed of the I/O interface is very much low when you compare with the speed of the core processor element. Remember, I can also call the core as a processing element, PE. So the processing element PE is nothing but the ALU, register and internal cache. Here internal cache is optional one because we may have external cache sometimes. So buying a single core processor is very difficult nowadays. What's happening? A total world is moving towards the use of multi-core processor. So it is very much important to have an idea on this.